Good day. In this video, we're going to prove this circle geometry rider. A part of this question is asking us to prove that the thing inside this red circle is a cyclic quadrilateral. So before we start with this question, let's quickly look how we can prove that something is a cyclic quad. One of the ways to prove that something is a cyclic quadrilateral is this one, and this is the one we'll use in this video also. It says here, if a line segment joining 2 points, that's the dotted line there, subtends equal angles at 2 other points on the same side of the line segment, then these 4 points are concyclic. They lie on the circumference of a circle. The abbreviation we will use is line subtends equal angles, or converse angles in the same segment. So if there is a line over there and it is sitting opposite 2 equal angles, this will be a cyclic quad, as indicated in this sketch. Just close that line over there, then we have a cyclic quad sitting with DABC on the circle circumference. The second way that you might want to prove that something is a cyclic quadrilateral is if you have a quadrilateral, and if the opposite angles of a quadrilateral are supplementary, in other words add up to 180 degrees, then the quadrilateral is a cyclic quadrilateral. Abbreviation we will use opposite angles of a quad supplementary, or converse opposite angles of a cyclic quad. So if we have a quadrilateral and that angle at D and angle at B adds up to 180, or the angle at A and the angle at C adds up to 180 degrees, then this quadrilateral ABCD will be a cyclic quadrilateral. The third way to prove that something is a cyclic quadrilateral is if you have a quadrilateral with an exterior angle over there equal to that one. Let's see what it says. If an exterior angle of a quadrilateral is equal to the interior opposite angle, then the quadrilateral is a cyclic quadrilateral. Abbreviation we will use exterior angles equal to interior opposite angle, or converse exterior angle of a cyclic quad. Looking at this quadrilateral with this exterior angle, so if this angle is equal to that one, the exterior angle is equal to the opposite interior angle, then this quadrilateral will be a cyclic quadrilateral. In other words, all the vertices will be on the circle circumference. Please stop the video and make sure you understand the 3 ways you may use to prove something to be a cyclic quad. Now let's go through our rider. Here is our sketch. They gave us next door some information. They said NP and NM are tangents to the circle. So the blue line and the red line are tangents to the circle. Next they said angle K is equal to X. So that angle over there is X big. Next they said that the 2 green lines are parallel. NL is parallel to KP. The first thing they're asking us to prove, they say required to prove NMLP is a cyclic quadrilateral. So the thing inside that red circle we must prove is a cyclic quadrilateral. So we have to prove that that blue quadrilateral is a cyclic quadrilateral. First thing we can write is angle L1 is equal to X is equal to angle K, corresponding angles NL parallel to PK. So that angle there is X, the angle there is X, there is the 2 parallel lines, and they are equal because they are corresponding angles. Next we can write angle P1 is equal to X, also equal to K. That angle there is equal to that angle over there. Tan chord theorem. There's the tangent, there's the chord, so that angle is equal to the one over there. So angle L1 is equal to angle P1 because they're both equal to X. Then we write NMLP is a cyclic quadrilateral. Line NM subtends equal angles. That line there subtends equal angles on the same side of it. Stop the video and get your head around this proof. Remember, before we go on, there is now a new circle that was proven to be on this sketch. Lastly, they ask us, required to prove that triangle KLP is isosceles. That blue triangle we have to prove is an isosceles triangle. First we may write NM equals to NP tangents from the same point. So that line and that line are tangent from the same point, so they are equal. Then we write angle M1 equals to angle P1 will also equal to X. Angles opposite equal sides of a triangle. So that angle there and that angle there will be equal because of those two sides of the triangle that are equal. Next we write angle L2 is equal to angle M1. It's also going to be equal to x. Angles in the same segment of this new circle NMLP. Angle over there is equal to that angle over there because of this new circle, angles in the same segment. Next we can write angle L2 is equal to angle P3, will also equal to x. Alternate angles NL parallel to PK. The angle over there is equal to the angle over there because of the parallel lines. Then you may write angle K is equal to angle X. It was given in the beginning. Then we can write triangle KLP is isosceles, sides opposite equal angles. Because those two angles are equal, the two blue sides over there will be equal. Stop the video and get your brain around this. Please indicate whether you liked or disliked the video and subscribe to the channel. Enjoy circle geometry.